Okay, hello and welcome back to the part 2 of the 2D prefix sum series, in which we actually try to apply 2D prefix sums in code to actually solve a real world problem. So in this case, the problem that we're going to solve today is the maximum sum of an hourglass problem. So this problem is actually solvable with brute force, the brute force method, but the brute force method is not necessarily the most time efficient, and I want to make use of this opportunity to actually show you how we can actually apply 2D prefix sums to solve matrix problems. So in this problem, what we are given is a definition of an hourglass. Okay, so this is how an hourglass looks like. Okay, it looks something like a T with one more row at the bottom. And what we need to do is to find the maximum sum of the elements of an hourglass. So in this case, in example 1, the maximum sum of an hourglass is 6212928, and this gives you the maximum sum of 30. You can try any other combinations of hourglass, they will not give you the maximum sum. For instance, you can try 21312887, or you can try 42124112, or you can try 2158129. But none of these will actually give you the optimum sum. Only 6212928 will actually give you the optimum sum. Okay, so if you have not seen this problem, I would highly encourage you to actually try giving it a go. Try using 2D prefix sums to solve this problem. Okay, if not, let me just quickly give you a run through in how we can actually use this data structure to help us solve this problem. Okay, so this is the actual array A. Okay, 62134215. This is the 2D matrix that I actually stole from example 1 of the problem on Leetcode. Okay, basically it's this exact is a carbon copy of this array here. And then what I've actually done for you is that I've actually calculated the entire prefix array P for this array A. So make sure you understand how 2D prefix arrays are actually calculated before actually moving on with this video. Okay, so how do we find, so let's say we want to find the first hourglass sum. Okay, 6219928. Okay, basically the boxes that are highlighted in red. And how we can actually use the prefix sum, right? The prefix array to actually help us is that first we can get 22 in the prefix array P, okay, which is 35, which actually contains the sum of the elements of this entire box here. But notice that this actually includes elements that we don't want. So what we can do is we can simply subtract the elements that we don't want. So in this case, we subtract 4 and we subtract 1. And this will actually give us the resultant hourglass sum that we want. But this is the most basic case. Now, why not you have a go at finding the hourglass sum for this case instead? So this is going to be a bit more complicated than our first example. Okay, so we're going to do this step by step. Okay, so first we'll get 66. Okay, 66 is essentially the last element of the prefix array P, and 66 definitely gives us more than what is required. 66 will give us the elements, the sum of the elements of this entire square, okay? Of this entire square, 6213, 6494, every single number in this box, which is definitely more than what we need. So we do it step by step. First, we'll actually minus 2 and 7, because we definitely don't need 2 and 7. Next, we subtract the leftmost column, because we also don't need the leftmost column in our computation. And then, we also subtract the topmost row, 6213, from our calculation. And at this point in time, you might have noticed that A00, okay, which is referring to this red element, the element 6, is actually subtracted twice from this array. So to actually rectify this mistake, what we can do is we can add it back. So we can add P00 back, which is essentially 6. And that is it to calculate the hourglass sum for this. So we can actually generalize our formula here to this equation. So if you're still not convinced that we can actually generalize to this equation, I would highly recommend you to actually try drawing everything out, the 2D matrix and the corresponding prefix sum on actually pen and paper, to actually come and visualize on how this generalization works. Essentially, how I came up with this generalization is I basically took reference from this frame. Okay, so let's have one more exercise in trying to find this in terms of prefix sums. So in this case, let's try to find this hourglass, okay, in terms of prefix sums using the array P. So the answer for this is pretty simple. So first we use 42. Okay, so 42 P32 will give us the sum of the elements of this entire rectangle, which is also more than what we need. So what we do from here, okay, is that we subtract the elements that we don't need first. So we don't need 9, we don't need 8, because the hourglass only consists of this particular shape, right? So we don't need 9, don't need 8, so we just subtract them individually. Okay, next, after subtracting 9 and 8, we still need to subtract the topmost row. Oops. We still need to subtract the topmost row. So what we do is we minus P02. So this will actually help us subtract the topmost row, which will only give us the remaining hourglass sum that we want. Okay, so notice that this is a lot easier, and the reason being is that the hourglass here is actually on the edge of the array. It's actually on the edge. So unlike the previous example, the hourglass is in the middle, so this is the most generalized form. But if we're dealing with edge cases, in the sense that when the hourglass is actually touching, okay, the edge of the array, okay, then notice that the calculation is a lot easier. So we will actually use the generalized form, and then we will actually create code to actually settle the base cases separately. Okay, so without further ado, let's get started coding the entire thing right now. Okay, so right now I'm on my C Lion, and I have some template code. Essentially, I include all my libraries that I need. I'll use namespace std standard so that I don't have to type so much code. And I have my grid, which essentially represents my actual 2D array. And I have MNN, which represents the height and the width of the grid respectively. So right now, let's quickly input whatever that we need. Okay. And then now I want to build my prefix sum. Okay, my prefix sum has to have the same dimensions as my grid, and then I'm going to initialize my my prefix array. And then from here, what I'm going to do is I'm actually going to start building. So this is where I actually start building my sum function, my 2D prefix array function. Okay, so again, I'll create a loop, and then I'll just loop through as normal. Okay, now this is the critical part. So first we got two base case. I got a base case. So essentially, okay, if you took a look at my previous video, you actually see this base case is the most basic base case, where my element is the top leftmost corner. So in this case, I know that my prefix is simply the topmost element. Okay. Else if I is equals to 0, so meaning if it's not the topmost element, but if it's the topmost row, then we can function this exactly like we can view this as a normal 1D prefix array. Okay, so pi minus 1 j pi j minus 1 plus grid and ij. Okay, else if j is equals to 0, then same thing here, pij equals to pi minus 1 j. Basically we get one row above, and then we just include the current element itself. Okay, last case is that we're just going to have pij equals, so this is the part where we'll use the inclusion exclusion principle. Okay, where we will just minus off, because we actually double counting that region of p I minus 1 j minus 1. Okay, this part is a lot more clear if you take a look at my part 1, where I actually show you visualizations. It's a bit more difficult to see in code, so I will highly encourage you to check out my first video if you haven't seen it yet. Okay, so from here we have actually finished the construction of our 2D prefix array, and just to make sure everything is working, what I'm going to do is I'm actually going to try to print everything in my prefix arrays, okay, just to make sure that everything's okay. Okay, so I'm just going to copy this. So this is the sample input from example 1 of the Leetcode problem, and let's paste it. And does this give us the correct input? Oh, we forgot to include the grid. Yeah. Okay, let's try it again. Okay, 66. Boom. Alright. So all's working good right now. Now, we're going to actually try to do this, try to apply this formula. Oops. We're going to try to apply this formula into our hourglass sum. And remember, we're going to include all these various base cases in the sense that when our hourglass sum is actually touching the edge of the array. Okay, so first I'm just going to loop through again. And notice that our very first hourglass sum, right? Okay, this is our very first hourglass sum. Our starting element, this is our starting element. Okay, this part 35 is our starting element. We can't go any more left or any more top beyond 35. 35 is our very first element. So we actually, our first has to be 2. Okay. Next, okay, so we'll start at 2, 2, 35 from here, and then what we first need to do is we need to minus these 2 red boxes. Okay, so I'll just create integer sum, and I'll call this p at I at j. Okay, then I'll need to minus those 2 red boxes, right? So those 2 red boxes are essentially just p I minus 1, okay, j minus 1, and then I need to minus the right box, and the right box is simply pi minus 1, but it's still in the same column. Okay, so now that I've subtracted these 2 red boxes, I'll need to settle the base case now. So I also need to subtract the top row. Okay, I also need to subtract the top row, and before that, to prevent the array out of bounds, right, I'll need to check if I is oh wait, no, I starts at 2, so it's fine. Yeah, we first need to check if I, because we need to subtract this this leftmost column, right? And from here 66, so 66 to get to 4, you need to do 3 0. We need to check 0, so we need to minus 3. Yeah, so if I minus 3 is more than equal to 0, what we're going to do is we're just going to sum minus equal. So this is what we do when we want to subtract the topmost row. Sorry, this is how we subtract the topmost row. Sum minus equal p I I minus 3 at j. Yeah, so this is how actually we subtract the topmost row, and we can actually do the same thing for j. So let's say you want to subtract the leftmost column when we want to subtract the purple row. So what we're going to do is we're going to subtract j, and this will be j minus 3. Okay, and then we also need to keep track if what happens if we subtract it twice. So what I'm going to do is that I'm going to create a variable subtracted. So this will actually help me keep track of how many times have I subtracted my row or my column. So if I've subtracted my top row 1 time, I'll just increase 1 time, and if I actually subtracted my leftmost column 1 time, I also subtracted plus plus. And if my subtractor is equal to 2, meaning if I actually subtracted my row and my column 1 time each, it means, right, I've subtracted my P00, my topmost element, twice. So I'll need to include it back as per the inclusion exclusion principle. Yeah, so I'll just add back this both. And lastly, I'll need an answer. And ans should be equals to the maximum sum ans. Okay, I think this should be the answer. I'm not sure whether this will work, so hopefully this might work. So sum is only defined, so we'll need to we need to put here. Okay. Oops. Okay, that's weird. Okay, let's quickly take a look. Sum minus equal, sum plus equal. Oh, this is supposed to be great. Yeah, because we are supposed to subtract the actual box in this case. We're just supposed to subtract these two red boxes, which is the actual elements in the array. We're not supposed to involve the prefix arrays for this. Okay, let's try it again. 32, it's still off. The answer is still off. It is actually, this should be I minus 2, sorry. This should be I minus 2. This should be sorry, this should be I minus 1, but this should be J minus 2. Yeah. Oops. Okay, let's try it again. Rookie mistake. Alright, we got 30. And I'm a feeling that this will actually exceed the boundaries of a signed integer, so we're just going to change everything to long just in case. What else should be long? Answer has to be long. My grade has to be long. P has to be long. My sum and answer has to be long, and I think it's fine. Okay, so now I'm just going to copy my entire code here, and I'm going to actually paste it on my Leetcode, and let's try to get a submitted on here. Okay. Okay, so let's paste everything here, and if I'm not wrong, we have to define m for them. So this m will just be in grade.size, and will just be grade at 0.size. Oh, then we need to define p for them. So p 155 and 155 grade. And then I'll need to forcecast this to long because there's a chance that they might overflow. Oh, I need to add my type definition for long as well. Let's quickly add here type def long. And then we need to return the answer after the end of everything. What else do I need? I need to change. So let's try running this and see how it goes first. Oh, accepted. Okay, let's try submitting it. Okay, and that's it for the hourglass sum problem. So it's not very difficult. Okay. So yeah, so that's it for 2D prefix sums. So let me know any more concepts you want me to explain, and I'll try my best to accommodate. Alright, see you.